Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss wave packet and Gaussian wave packet. Let's begin. What is a wave packet? A wave packet can be constructed by the superposing a large number of waves so that they interfere either constructively or destructively in a localized region of space. Okay, or how a wave packet represent a particle? If the localization is constant in time, then that can be represent a particle. Now mathematically we can show what should be the wave packet. Suppose a wave packet is formed by the superposition of a number of waves propagating in let x direction. Hence, that wave packet is represented as psi xt, the wave function, and that for that of wave packet it will be summation over n a n e to the power I k n x minus omega n t. That is equation number 1. Here where a n be the amplitude of nth wave and k n the wave vector for nth wave, and omega n is the angular frequency for nth wave. Now if we choose the continuum values of k, we can replace that sum by an integral. Let I write here, if we choose a continuum values of k, like k1, k2, like the number of waves it will be, we can replace the sum by an integral. Hence, that above equation changes to the above equation 1 becomes that will be psi as a function of xt, the summation changes to that of integral limit minus infinity to plus infinity a k e to the power I kx minus omega t dk. That is equation number 2, where a of k is the amplitude of psi of k and its corresponding momentum p will be h cross k, and wave and that that of omega is a function of that vector wave vector k. Omega, here omega is a function of wave vector k, Now this will be the equation that represent a wave packet. That is the equation for that of wave packet, and that summation changes to that integral representation. Now you have to study a special type of wave packet that is known as the Gaussian wave packet. The form of wave packet, the wave function representing a wave packet, let I write here the wave function representing a wave packet is given by, that is psi a function of xt is equal integration from minus infinity to plus infinity b of k e to the power I kx minus omega t dk. That is equation number 1, where b is a function of k, where b is a function of k and that one is a Gaussian function. That represents a Gaussian wave packet only if the condition as that b of k will be how much, e to the power minus k naught square alpha. If b will be that much, then we can say that particular wave function represents the Gaussian wave packet. What is that one? That means it is in a k space, that indicates it is in k space and has the peak value will be k naught. K naught is the peak value, and where alpha is some constant. This for that representation. Now that equation 1 will be, therefore that equation changes to, therefore equation 1 will be psi as a function of xt is equal to integration from minus infinity to plus infinity e to the power the value of bk here, that is minus k naught square alpha into e to the power I kx minus omega t dk. That equation number 2. At time t is equal to t naught, here I choose at time let t is equal to 0, not t naught, that is t is equal to 0 at initial time. The wave function psi xt change to only psi is a function of x, and hence the Gaussian wave function, the Gaussian wave packet becomes, that will be psi of x will be integration from minus infinity to plus infinity e to the power minus k naught square alpha into e to the power I kx since t is equal to 0 dk. That equation number 3. Now substituting here, substituting let s is equal to k minus k naught, s is equal to k minus k naught. What we have, we get that equation changed to that of equation changed to, you can write here like this, psi function of x integration from minus infinity to plus infinity e to the power minus s square alpha into e to the power I, in place of k I can substitute s plus k naught into x dk, sorry, then dk changes to ds, as s is equal to this much, there will be, we can write here ds will be dk, okay, is equal to integration from minus infinity to plus infinity e to the power minus s square alpha into e to the power I s x into e to the power I k naught x ds. Here e to the power I k naught x is a constant term, since it will be no such term like s, therefore that term treated as constant, that constant term to that of outside, e to the power I k naught x integration from minus infinity to plus infinity, the term will be like this, e to the power minus s square alpha plus I s x I s x ds, e to the power something, e to the power something, that means e to the power are its exponent values. Now I prefer here like this, e to the power I k naught x into e to the power minus x square by 4 alpha, integration minus infinity to plus infinity e to the power minus square alpha plus I s x into e to the power plus x square by 4 alpha ds. I just multiply these two terms, one is positive, another one is negative, there will be no such change. Now it will be e to the power I k naught x to e to the power minus x square divided by 4 alpha in that of bracket term. In that of bracket term, it will be integration from minus infinity to plus infinity, that will be e to the power, the term looks like this, adding these two terms it will be minus 4 alpha square square plus 4 I s alpha plus x square divided by 4 alpha into ds, 4 alpha ds. This entire term can be written like this, e to the power I k naught x into e to the power minus x square by 4 alpha, integration from minus infinity to plus infinity, that will be e to the power, that term like x plus 2I s alpha divided by 2 under root alpha whole square ds. Okay, just I partition that particular term into the square of these two terms. Now see the value of psi of x. Now we further substitute, let we put here, let write the term like this, let q is equal to, I substitute x plus 2I s alpha, 2I s alpha let q is equal to x plus 2I s alpha divided by 2 under root alpha with the value of q. Therefore dq will be same as that of ds, all terms are constant. This substitution made here, what we have, we get, that is psi x is equal to e to the power I k naught x into e to the power minus x square by 4 alpha into integration from minus infinity to plus infinity, that term will be e to the power, the term looks like this, alpha e to the power here the terms e to the power e to the power q square dq. E to the power q square dq. Now e to the power q square dq, that value e to the power q square dq value is same as that of gamma function value. Once I have a confused here, when dq that will be same as 2 to cancel out, 1 alpha must be cancel out, that value is similar to that of e to the power minus alpha, a term will be there, just as the term it will be possess the term like one alpha cancel out under root of alpha here, I under root of alpha, I under root of alpha, and that can be written like this here, e to the power minus alpha q square, e to the power here e to the power minus alpha q square. Okay, now psi of x is equal to e to the power I k naught x e to the power minus x square by 4 alpha into that integral value is nothing, that one is under root of pi by alpha under root, the integral value of that quantity. Now psi of x is equal to, let I prefer that term and that term combining as f of x e to the power minus x square by 4 alpha, at equation number 4. Here where f of x, that is e to the power I k naught x into pi by alpha under root, the factor e to the power I k naught x, the factor e to the power I k naught x is the phase factor, and therefore that phase factor e to the power I k naught x magnitude is equal to 1. Therefore, the magnitude of f of x square is equal to pi by alpha square root square is equal to pi by alpha, and again the magnitude of the wave function psi x square is equal to psi x square f of x the magnitude and its magnitude square, that is pi by alpha into its square e to the power minus x square by 2 alpha. Hence we can say that psi of x satisfy all the rules of that Gaussian function. Hence psi of x, that wave function, is a Gaussian function of x, a Gaussian function of x. Therefore, as we consider that wave packet is known as the Gaussian wave packet. Here, with the help of this video lecture, we understand what is the mathematical representation or the concept of wave packet. We mathematically represent it, and a special type of wave packet which is known as the Gaussian wave packet, and it is written like this mathematically. And here we proceed accordingly. The proper substitutions taken for that of mathematical methods, and finally get that equation and putting the conditions for that of Gaussian wave function, and finally we get that function psi of x is a Gaussian function of x, and that equation is the Gaussian wave packet equation. So, with this useful and informative notes, let me wind up this session. Thank you.